Okay. So the question was, what separates a cryptographic hash function from a non-cryptographic hash function? And the answer by Chris was for any small change in the input, the output needs to be very different. In essence, right? And there are a couple of other differences.
And the results need to be as distributed as possible.
And the results need to be as distributed as possible. Yeah, this is cryptography. We encourage you to go and read up on it, but don't be sad if you don't get it the first time. It's a bit involved. Just like this next one. So look at another problem. We talked about Alice and Bob. They wanted to compare answers, but not actually give away those answers. And that's why we use cryptographic hash functions to solve that problem. Now let's look at another problem. I send some data on the internet. How do you know that data came from me? Right, you're gonna trust me? Hey bro, that was me. It doesn't make sense. Right. So you do that through public key cryptography. Now before we talk about public key cryptography, let's talk about cryptography in general. There are two types of cryptography, symmetric and asymmetric. By the way, I'm not a cryptography expert. You don't need to be a cryptography expert for this. But you need to know some basics. Two types of cryptography, symmetric and asymmetric. What is symmetric cryptography? I give you some data, and I'm like, okay, so I'm gonna be traveling through Russia, and I need to make sure that my mom's grocery list is not read by the police. Okay. So I'm gonna encrypt it with some password, and I'm gonna give that password and the encrypted list to my mom so she can decrypt it. She wrote it, she should know, but you're gonna use the same key to encrypt and decrypt that string. Asymmetric cryptography is I use one key to encrypt it, and you can use another key to decrypt it. Make sense? Make sense? I don't know your name, so.
Me?
No, behind you. Behind you. Yes?
Yes.
Okay, good. So the encryptor uses one key, the decryptor can use another key. The decryptor uses, wait, what? Yeah, in asymmetric cryptography, the encryptor uses one key and the decryptor uses another key, right? So let's talk about public key cryptography. It is a class of cryptography which is asymmetric. So when I use public key cryptography, I'm going to come up with a private key. We're going to talk about what that private key is in a bit. You can derive a public key from the private key. So this is a public key because I can share it with you. And you can't go back from the public key to the private key. So I can share that with the world and be rest assured no one can come up with the private key that I have. Right? That property, that it is near impossible to derive the private key from the public key that I gave to everyone, it is essential in this. If you are able to break that, you break public key cryptography. And that has not yet occurred. So you can hand this public key to strangers, they can encrypt data with your public key, but only you can decrypt it because only you have the private key. Okay? So that question where I'm sending some data on the wire, and how does the recipient know that that data it came through me? I can use this private key to sign that data or a representation of that data. So when that recipient receives it and they have my public key, with that public key they can instantly verify, okay, this signature belongs to this public key and this signature is locked to this content because of cryptographic hash functions. Everyone still with me? Right, what's an example of public key cryptography? It's Bitcoin addresses, right? An address is a representation of a public key. Now let's look at that right now. Okay, so I'm using a service called Brain Wallet, and the URL is brainwallet.github.io. Do not create addresses that hold money from this site. Just use it for instruction. So I can type in a passphrase, right? So I can type, I am a little teapot, right? So what it did was it created a SHA-256 hash of that input. I am a little teapot. And so this thing is really my private key for general purpose. It's not my Bitcoin private key, but it is the private key as far as public key cryptography goes. Now, we pass that private key through a one-way function, and we come up with a public key, which is this very long string. It doesn't need to be this long, but for now it is. Right, so you have a public key derived from a private key. Given this public key, you cannot determine I wrote I am a teapot. And we use this public key to derive the address that you share with other people. So the Bitcoin address is basically a public representation of a private key that are generated. Make sense? Yes?
If I type in, I'm a little teapot, do I get the same results?
Exactly the same. As long as, I don't have spaces in the beginning or at the end. So. Yeah, we're going to demonstrate with that with the Node.js thing we'll do. You should come up with the same thing. Yes?
If I have the public key, can I decrypt the message? Or only with the private key?
On both ways.
Works both ways, Chris says. So in Bitcoin, Bitcoin uses public-private key cryptography to ascertain the origin of the message. So we are using it for signatures, not encryption and decryption. Okay? So when I send a message into the network, I will sign it with my private key. I can't sign it with the public key. It doesn't make sense. Okay? When the recipient receives it and he sees my signature and my public key, or has my public key through other means, they can take that public key and verify that this message was signed by the private key for this public key. Okay, that's what we use it for in Bitcoin. There are other users out there as well. Make sense? So what is the Bitcoin address that you share with people? It is your private key passed through a one-way function. And that is basically your public key. You're sharing a version of your public key. You can use the same secret to come up with different addresses for every single network, like Ripple or Bitcoin or Litecoin or Dogecoin. And their addresses will all be different because there are different versions of the public key. But their public key will be the same because it's the same private key. Okay. Yes?
What's the secret exponent here?
So on this site, the secret exponent, that's the question. What is the secret exponent? It is the SHA-256 hash of the sentence, I'm a little teapot. Okay. We're gonna go through this in a bit. Okay. All right. Let's get back to this. All right. So what are the keys? We're talking about taking SHA-256 hash of a string, and then all of a sudden you have a public key. How do you even get that public key? Well, private keys in general are basically very, very large integers. Right. In Bitcoin, we use 256-bit cryptography, and that basically means our private keys need to be anywhere between the integer 1 and 2 to the power 256 minus 1. So really, when I talk about private keys, the number 2 is a perfectly valid private key, except it's not private. Right? I just told you about it. And it's really easy for you to try. Usually when you're brute forcing or trying to figure out other people's keys, you will start with a small number and then work your way up. And you will hit my private key in a couple of iterations. That's not good. When is a private key secure? It is secure when it is random. Yes?
2 to the 256 is basically a little bit larger than 1 followed by 77 zeros decimals. So it's an extremely large number.
Right, the comment is, it gives you an idea of how large this number is. 1 followed by 77 zeros.
Slightly larger.
Slightly larger than that. Right. I think in the first presentation that I gave for blockchain U number 1, I was looking at stats and it said this number is larger than 70% of all mass that of all atoms that exist in the universe. Yes. And that was profound. So what you were trying to do when you come up with a random integer, and that's your private key, and someone else is trying to break it, they're trying to find one atom in the universe. That's not cool. Don't make me do that. The easier way of finding your private key is just breaking into your computer and extracting it from your unencrypted files. I would definitely pick that. Okay, Bitcoin uses, so this private key, it needs to be converted into a public key somehow, right? You do that by performing operations on an elliptic curve. So Bitcoin uses elliptic curve cryptography. This curve is defined by this equation and a few other parameters. Right. The details of this are really something you don't need to worry about because you won't be creating this stuff yourself.
Yeah, this is hard stuff.
Yeah. So just to give you an idea of what's happening when we convert a private key into a public key, you are taking this random integer and you are performing addition and multiplication operations. But they're not really addition and multiplication operations. Those are made up operations that you are performing on this curve. And that is how you get a public key. Specifically, you take a parameter of the curve called the curve generator point, and you multiply it by the private key, except it's not really multiplication, it's something else, something completely made up for elliptic curves. And the result is a public key. Now, if you just look at this equation and you miss what I just said, you will say, oh, so I can just divide the public key by the curve generator point and get your private key. Haha, I broke Bitcoin. You're wrong. You didn't. Because this is not multiplication. This is something else. You just call it multiplication because people that were doing it were tired of creativity. Not to diss anyone, but. Alright. The result is not a Bitcoin address. How do you derive a Bitcoin address from a private key? Okay, this is tough. You first generated a private key, right? So I'm a little teapot, short and stout. Shout 256 that, you'll come up with something like that. 256-bit hexadecimal string, right? And then you multiply that by the ECDSA sec P256K1 curves generator point. You multiply that and you will get the public key. Okay. Now, you have the public key. Now you need to come up with a Bitcoin address. The way you do that is you pass it through two hash functions. One is SHA-256, the other is write MD160, which gives you a 160-bit answer. Then at the end of that, you append a checksum of this string. Right? Why do we do that? We'll find out in a bit. But you append a checksum. There is no science to this, by the way. This is something that wasn't made up, so you just have to follow it. So you append a checksum at the end of the write MD160 result. Then you convert that. Now this is going to be really hard for everyday users to enter. Bitcoin addresses already are. This is harder. Right? So we gotta give them something that they can reliably enter into their forms or wallets or something else, and not make a mistake. So you make it a little easier by converting this hexadecimal string into its base 58 representation. This step is called base 58 check encoding. Check because you encoded a checksum in it. The result is a Bitcoin address that starts with a 1. It starts with a 1 because we appended, we pre-appended this string with a predetermined version byte for Bitcoin, which is not shown over here. So let's go through that again. You have a private key. You multiply that by the curve generator point, you get the public key. You pass it through a couple of hash functions, append a checksum to it, and then you base 58 encode it. You come up with this string that looks like a Bitcoin address, right? Now, this checksum, it means any changes in this string are most likely not going to give you a valid Bitcoin address. So don't be scared of entering the wrong Bitcoin address if you're making one or two mistakes in your Bitcoin address when you enter it. It used to really freak me out when I would enter an address manually in a wallet. I was like, oh my god, my coins will go to someone else and he'll be really happy, but I'll be really sad. And then I found out about the checksums. Right? This thing protects you. The base 58 check encoding. So you can enter wrong addresses, just don't do it too often. You might come up with a case where the checksum is valid. Right. Again, getting a Bitcoin address, get the public key from the private key, base 58 check encode it, and the result is a Bitcoin address. Right. At this point, we're going to start diving into transactions, but before that, yes.
The one interesting thing about base 58, I don't know if you mentioned this, is like the 0 and the O are not, like, it's omitting zeros and I's and L's or something like that, right? Or ones and L's.
Right, so the comment is, one cool thing about base 58 check, about base 58 is it uses an alphabet which tries to disambiguate between characters. So it has no 0, it has a 0 and no O, right?
Something like that, yeah.
Yeah. So when you're entering the address somewhere, you're not going to be confused by L's and ones and I's and capital I's, and so it tries to take care of that. It tries to make it easy for you to use these addresses, but it clearly didn't do too well of a job, because we find it really hard to enter these addresses everywhere. Yeah.
What prevents you from sending a transaction to an invalid address? Is that the wallet software, or do miners know not to pick up an invalid address transaction?
Right. The question is, what prevents us from sending coins to an invalid address? The network does. The network is so whenever you try to send coins to an address, that address is not something directly on the network. It's actually the hash 160 representation of it, right? So, like over here, when you enter an address, we're gonna strip it away and reverse back to this thing without the checksum. Okay? So if the base 58 decoding fails, then that's an invalid address. Okay? Because it's gonna compare that to the checksum. You can send coins to any 160-bit hexadecimal string. That we don't check that. Make sense? Anything else?
When the transaction's actually broadcasted, though, is it you're broadcasting your
160.
the 160, not the final encoded address, right?
When you transact and you broadcast a transaction,
When your wallet broadcasts the transaction.
right? What exactly are you transmitting? You're transmitting the hash 160 of the address, not the address itself. We're going to look at that when we talk about the Bitcoin scripting language, and that actually brings me to. You guys needed that?
I was seeing what the name was of the third.
Oh, right MD 160.
Okay.
So,
Yes.
so in this, all these strings, there is no transaction, right? This is all about the keys.
Yep. This is all about the keys, no transactions yet. We're diving into transactions in just a bit.
Okay, and for those transactions, one of these keys will be matched to go through the blockchain. Is that what it is?
So, yeah, we're gonna go in deeper into transactions right now. We're gonna make a transaction and get you a little comfortable with that. Yes. Yes.
Is it the checksum in the right MD 160 number that detects and corrects errors if you type the wrong address?
So the question is, what prevents you from getting the right address when you enter something, when you enter a typo? It's the checksum, right? Right. Last one.
So you say that the wallet is taking care of the rehash from base 58 back to right MD, and that's why when you type in the wrong address, that's where it gets taken care of, not the network.
The question is, the wallet is actually handling the decoding of this. So, the network is not actually handling user errors. The network will do whatever you want it to do, because you can send coins to any of these strings. There is no validation, there are no checksum in there. But a Bitcoin address, you can validate it before, just to remove some user error. All right, let's go into transactions. What is a transaction? We talked briefly about it. A Bitcoin transaction is a set of instructions for transferring coins from one or more entities to one or more entities. Okay, it could be yourself too. It could be the same entity. So when you make a transaction, you're saying, hey computer, move my coins from boxes A and B. A and B boxes are boxes that I own. Move the coins from there and give them to C, D, and E, and the remainder back to B. Okay, that's a set of instructions. That is basically a transaction. A transaction, more specifically, consists of inputs, the drawers A and B that I'm taking the coins from, and outputs, the drawers C, D, E, and B that I'm sending the coins to, and some conditions attached to who can spend these coins and when. Okay. The instructions are encoded in the Bitcoin scripting language, and we're going to talk about in detail what that scripting language is in the next session. But for now, just assume that these instructions prevent the wrong people from spending your coins. And this could be a puzzle as well. So, the typical script in output of a transaction will be only allow the user who owns the private key to this public key to spend these coins. So when you send coins to an address that is mine, you are appending a script to it, which is basically the default script that says only allow Atif or anyone that holds Atif's private key that translates into this public address to spend these coins. So the next time you make a transaction, you are going to take the reference to those coins that you received, and you are going to sign that script with your private key. That's how the network knows that these coins are being spent by the person that actually was supposed to spend them. Okay? So there are some signed inputs, there are some unsigned outputs, and it keeps on going like that. Each transaction is a chain of transactions that came before it, all the way to the coins that were generated. This is complicated. Let me know if you have questions. Yes?
So for the set of outputs, it does specify the public addresses that you would need to have the private key for. And there's just one script for all of the outputs?
Right, the question is, the script specifies what address is supposed to spend those coins. Yes, so let's look at a transaction. It's beneficial for us to do that. So this is a blockchain explorer called chain.so. It was built for Dogecoin, but then it expanded to Bitcoin and Litecoin and all that. So it's used by a lot of people. It's a free API. You don't need to pay us anything for it. You can start using it whenever you want. Let's look at a transaction on it. You can look up any transaction that has occurred in Bitcoin's history on this, and we'll give you the data that was indexed by us as soon as the transaction occurs. Right, so we're looking at a random transaction, Bitcoin, that just occurred on the network. And the first field is the ID of the transaction. This is the hash of the contents of the transaction, right? Cryptographic hash functions, that's it. It has not been confirmed yet, so it's unassigned to a block, and it belongs to the Bitcoin network. Confidence meter is something a little more advanced. We're going to talk about that later, but it's not part of the Bitcoin protocol. It's something we derive from it. So there are 0 confirmations. It has not been confirmed yet. This transaction has 1 input and 2 outputs, right? So there is 1 location we're taking the coins from, and there are 2 locations we send the coins to. And I'm going to talk about the rest in a bit. So the inputs of this transaction, they come from this address, and these were the coins that were in this address. Now, when I say address, these coins that are in the output, they can't be spent at a later stage, right? They will become inputs in some other transaction. Make sense? So transactions are linked to each other in this way. There can be no transaction except for when you find a block where a transaction is not linked to a previous transaction. Okay? A transaction can never spend coins except for the case of generating new blocks where there is no predecessor where it's trying to spend those coins from. Okay? So if you look at these outputs, these outputs can be spent elsewhere. Now this input was also an output at one point, right? Let's go to that. The output that we're trying to spend is output number 1 in an earlier transaction. And these are the coins that were in this location. So there are 2 outputs, 0 and 1. And with these outputs, there was a script attached to it. Right? Don't worry about what the script is right now. Just consider that this script specifies the hash 160 of the address that we sent the coins to. And this script is basically saying, check the signature of the guy or girl that spends these coins. If the signature is valid, allow them to spend the coins. That is, the transaction is valid. Right? So we go back over here. The input in this transaction, this is the signed output of the previous transaction that we are trying to spend, right? And the new transaction outputs, they have their own scripts and own conditions, right? Those conditions can actually be something like allow anyone that can solve a specific puzzle to spend coins. So that puzzle can be stuff like, what is the answer to 3 plus 5? And anyone that can give the answer, you can specify that through a Bitcoin script. Anyone that has the answer will be able to spend the coins. You can attach no condition to it, right? Anyone who is anyone can spend these coins, right? And transactions like that have occurred on the Bitcoin network. And they're creating and spending those transactions is a fun way to learn the Bitcoin scripting language, but it is complicated. So again, don't be disheartened if you don't get it the first time. Any questions? Yes.
So it looks like that string 1 to VXN,
Yes.
if you go all the way back,
Yeah.
does that mean that string was generated when that coin was mined? So the question is, I have somebody mined a Bitcoin, one coin, it got some address. Now it's splitting into 0.25, 0.27, and they are going all over, but they are keeping that original address, and they are keeping, like they are merging and they are splitting, merging, splitting, but let's say it goes somewhere to 0.1, still we can go back and go back with that route. Is that what it is? I mean, what is that, why that number stays same on the transaction?
The question is, why does the address stay the same between transactions? It doesn't need to stay the same. So every single time you create a new private key, you are creating a new address, and you don't need to be connected to the internet for that. You don't need the network's permission to create a private key and an address. You can create as many addresses as you want while you are not even talking to the network. The only time the network recognizes an address is when you send coins to it.
But as he said, the value was created by the miners on the right there. That string, anybody can create this.
I hear some confusion between addresses and like Coinbase transactions that a miner generates, and what I heard was a confusion that these coins are born into a specific address, and that's not true.
Right. So the comment is, we have to look at Coinbase transactions. So let's look at that. The Coinbase transactions only occur when you find a new block. Okay. We're gonna let that load. It's a pretty big block. Right. So if you look at this block, it'll say the inputs are newly generated coins, and those coins have been sent into these two addresses. Now let's look at that transaction itself. These are newly generated coins. They were awarded to the miner that found the block. And the miner said to the network when he was finding the block, these coins that you are going to award me, send them to these addresses. These are the addresses you specified, these are the amounts you specified, and that's where the coins went. Now these addresses will sell the coins at whatever location, exchange, local Bitcoins, whatever, and they will keep progressing through the network for eternity like this, right? So they have not yet been spent, but someone will come in and spend these coins, and then they will spend these coins, and then they will spend those coins. That chain of transactions for these coins will always lead back to this Coinbase transactions, and there is no previous transaction to this Coinbase transaction. Make sense?
So anytime there is a transaction, it's a 10th or 15th transaction, not transaction, but it happens like 15 times, iterations. So when there is a validation happens, that this is a genuine Bitcoin, it comes all the way to this root to see, is that what happens? No.
So the question is, how do you validate transactions? We're going to talk about how we validate transactions at a later point, because that goes into Bitcoin scripts. Okay. Yeah, you don't need to go 15 levels up to make sure a transaction is valid. You can just do it by looking at that transaction and its ancestors.
So how can you trace back to the Genesis clock?
Okay, these are kind of disconnected, but I'm just going to answer that one. How can you trace coins into to a Genesis block? What is a Genesis block? The Genesis block is something Satoshi created when he was mining the first block in Bitcoin, right? Every transaction is a linked list all the way back to coins that were generated at some point with a new block. That's how you get to a Genesis block. Make sense? Right. Let's move forward.
Sure. Quick question. So the miner earned 25 Bitcoins for successfully mining, and then is the 617, is that the transaction fees that he also got for mining, and then those transactions were done?
Right. So the miner, the comment is the miner earned 25 Bitcoins because that is the reward Bitcoin network is giving away at the moment. What is 0.0617 8532? That is the fee from the transactions, like you said. So there are some transactions included in that block. Each one of those transactions is giving up some fee, right? So over here, this is giving away 0.0002 Bitcoin to the miner, and these are fees that you and I specify when you push a transaction into the network. Otherwise, the miner has no incentive to pick up our transaction and put it into a block and validate it as quickly as possible. So if you're in a retail setting and you're trying to pay for coffee, you're not going to get your coffee because you didn't pay a fee, and the network is not validating your transaction. So you're gonna have a pretty crappy day. Always pay your fees. It's like death and taxes and then Bitcoin fees. Right.
Quick follow-up question to that. Why were there two outputs if one had zero value? Is that second one necessary?
The question is, why were there two outputs if one of them has zero value? Zero value outputs are considered okay for now. They're non-standard, but they're okay. So these are rules that are written down in the Bitcoin source code, and you can find this source code on GitHub/Bitcoin/Bitcoin. Okay. And this is something they consider okay in that code, and most miners will use the same code and therefore adhere to the same set of rules. Okay. But this is non-standard. They're phasing this stuff out.
Unless it's an operator.
Sorry?
Unless it's an operator, that's not being traced out.
Operators may go away.
Okay, a little advanced, guys.
Alright.
Let's look at what a transaction is. So we've looked at a transaction in a blockchain explorer. How about we create a transaction for ourselves? It would give you a nice little kickstart for whatever projects you want to build on. Right. And then after that, we'll talk about the homework. So whip out your Node.js, open the console, type node. Just follow me over here. Okay. If you can't see this, let me know. We will fix it. Right? Right. So we're going to start up. I can't hold this. Right. I'm going to speak loudly. Right. So we will start up node like that. And actually, you know what? Just exit node and do npm install bitcoin.js-lib. That is the open source Bitcoin library in JavaScript that we will use for creating a transaction. Bitcoin.js-lib. npm install Bitcoin JS -lib. Okay. Let me know if anyone's waiting on the network. Okay, the next package we will install is crypto-js. npm install crypto-js. Right? Anyone waiting on the network?
What if you get something that says attempt to unlock, which, you know, is a big phrase, which hasn't been locked yet?
I don't know.
Oh, yeah.
Jeff, what?
Yeah.
So just a heads up, I'm as new to Node.js as most of you are. So I just looked at this yesterday. So I shall stumble with you. Okay, right, let's, everyone okay? Good? Hey Jeff, would you help? Are you good? Okay. All right, let's start up our Node console. So just type Node and press enter, and you should get into this command prompt. Let's start with something simple. Let's start with calculating the SHA-256 hash of something. Right? So let's do way down. Right, so just type var SHA-256 require crypto-js / SHA-256. This imports the SHA-256 hash function that we can use within the command prompt. Right? So we go in, now let's calculate the SHA-256 hash of, I am a little teapot, and type it exactly like that. And then let's convert that into a string, because it's going to be an integer and there are a lot of weird values in there. You can test it out if you want. Right, so you're going to come up with a 256-bit result as a hex string. Now if you go back to this thing, I am a little teapot, you can see that it starts with 124A3E. You can say same thing, 124A3E. It's the same result. For the same sentence, for the same input, you will get the same result from the SHA-256. Right? So that's a cryptographic hash function, and you just did some hashing on your own. Congratulations. Now let's try and create a transaction, because being able to create a transaction by ourselves, it'll give us something we can be very proud of. Right, I'm just going to test it right now. Right. I'm gonna start fresh. So do var Bitcoin equals require. So we want to import the Bitcoin JS library that we installed. Right. Okay. Now let's create a random key in the Bitcoin format, the way it wants the private key to be. So we're going to create a new key, and this syntax is a bit odd, and this is why you need to go and look at the documentation for Bitcoin JS lib, or just look directly at the source code on GitHub. That's how you will find the functions that you're supposed to use. So in order to create a new key, a random one, this is the command you will type in Node.js. And it should give you a key with a lot of different things in there. And we can use that key for cryptography purposes for our Bitcoin thing. So let's get the address of this private key in Bitcoin. Right? So we'll do key.pub get address. It gives you the address in hexadecimal. So let's look at key.pub.getAddress.toString, and that gives you a Bitcoin address. Now that's if we keep trying to get the address for the same thing, we're going to get the same address. We're trying to get the address for the same key. Let's do something more fun and create a new address on every single line. We'll do bitcoin.ec.make random, and then we will get the public key of that, and then we will get the Bitcoin address out of that. Okay? Oh, sorry. And then we're going to convert that into a string as well. Right? If you're into that, you're going to get a new Bitcoin address every single time. This is you creating a new bank account every single time. See how easy it is? And that's pretty cool. Right? So you can don't send coins into any of these, but you can send coins into any of these. And whoever has the private key, I don't have the private key either because I didn't save it, will be able to take those coins out. It's as simple as that. You don't need to know their identity, you don't need to know their life history, you don't need to know anything about them.
I have a question.
Yes.
So can I just keep generating private key public key pairs, and then hopefully I'll get enough private keys that I have value in them?
Yeah.
And I mean, I basically have whoever has the money, I have control of that money, right?
Yep. So the comment is, I can just keep on generating private keys, and I might hit upon a private key that has some money in it. Yes, that has occurred a couple of times. It's actually occurred more than a couple of times. So, as an aside, as a security aside, blockchain.info had an issue where one of their engineers pushed code that was not randomizing private keys. So new people that were creating addresses, they were using a seed that was not actually random. And what that is, you can Google it up and find it on your own. But the feed actually helps you randomize or introduce some more randomness into the answers you will get out of a randomizer. Yes?
On the last 7 sets of public addresses that you generated, do each of those have a distinct private key?
The last few addresses that are generated, do each of those have a distinct private key? Yes. So what we've done over here is, if you look at all the way up until here, bitcoin.ec_key.makeRandom, I'm creating a new random key every time. So what that random key is really an integer between 1 and 2 to the power 256 minus 1. Right? And I'm converting that into an address by getting its public key.
So where's the associated private keys to those 7 public keys?
You want to print out the private key?
No, but where is it?
It's I lost it. I didn't save it. Yeah. So the question was, where is the key for each one of these addresses that I generated? I didn't save it, so I lost it, and I probably won't find it again. Yes.
Just a quick, I mean, the key, randomness is really important, and most of the time you're relying on libraries that have been very well studied. Randomness is the number. First thing a cryptographer looks for. There were a couple people in the room who said they were talking about doing the Internet of Things. You cannot rely on a standard library for a lot of randomness on small devices. So if you're really wanting to do this on some kind of small device, you need to, you may not be getting random numbers on that small device. So it's the most common attack against Bitcoin right now is randomness.
So Chris's comment was, you want to make sure your private keys are random. Don't just generate them out of things you don't trust. One of the strongest attacks on Bitcoin right now, the strongest attack on Bitcoin right now is attack on randomness. You got to understand, we don't have random number generators, we have pseudo-random number generators. So make sure you're using one that is actually vetted by cryptographers. Yes, last question.
If you have a value assigned to some address and you create a new public or private key, how do you transfer the value to that new address? Do you have to do a transaction?
How do you transfer some value into an address? Great question. We're gonna dive into that. Yes, you make a transaction from your wallet or wherever you bought those coins from, BitPay, Coinbase, whatever. Local Bitcoin. Don't go to Coinbase. I'm kidding. Right. So with Bitcoin, there is a live network that all the real transactions occur on, right? And these are coins that hold value. So there are people doing a lot of hard work in order to generate these coins, and then you're able to buy these coins from them. There is some value assigned to it. There is some real world monetary value assigned to it. When you're building software, and all of us build buggy software, at least in the beginning, you're gonna make mistakes. You don't want to build software that is moving real money around, right? You use a testnet for that. What is a testnet? It is a network just like Bitcoin, except people don't ascribe value or monetary value to coins on this network, right? And you can get free coins pretty much anywhere. So if you go to block.io and you sign in or sign up, you're going to get some free Bitcoin testnet coins. Let's do that now. I'm going to create an account. It's going to ask me what plan I want. Just skip to the free plan. And I'm going to generate a secret pin that encrypts my private key, so I don't need to worry about handling the private key and losing it or whatever. So it's generating the secrets or private keys, it's encrypting the private keys, and then it's asking me to write this thing down in case I lose my my secret pin, so I have something to recover it with. Right? And then I'm sending the secret into block.io. Block.io is backing that up to 4 different continents, so it can't be lost. So you can come back to block.io and you're in control of the money, not block.io. Right. So if you go to the Bitcoin testnet over here, you will see that you have some free testnet coins. 0.01 Bitcoin testnet. And we will use these coins to fund our new Bitcoin testnet account that we will just now create. Right. Now this gets a little choppy because the syntax, I'll have to look it up. Hold on. Alright, this is a case of I have no idea what these commands are, so I'm going to go into the source code and look at them. So what we're looking for right now is a way to specify that I want to create a new address for the Bitcoin testnet and not the live Bitcoin network. So I want the address is for the Bitcoin testnet. For example, if you go over here, they don't actually start with a 1 like the Bitcoin addresses will. The Bitcoin addresses will start with a 1 or a 3. These addresses start with M or N. Right? Bitcoin testnet addresses. So I'm looking for an address that is valid on the Bitcoin testnet and not valid on the Bitcoin livenet. So I'm going to dive into the code and figure out a way to specify that I want to get a new address for the Bitcoin testnet. So I'm going into the node modules library in my home folder, and then I'm going into Bitcoin.js lib, and now I am going to look up code. The reason I'm looking at up in my own machine is because the version of Bitcoin.js lib that you installed is not the same on GitHub. All right, we're going to try it again. Right, perfect. So we are generating a random key, bitcoin.ec_key.makeRandom. Then we're getting the public key out of it, .pub. Then we're getting the address out of it, .getAddress, open bracket. And we specify that we want it for the Bitcoin testnet. If you don't specify this, it will create it for the livenet. So we open the bracket and we say bitcoin.networks.testnet. And then we convert that thing to a string. So we say .toString at the end. Again, this is bitcoin.ec_key.makeRandom.pub.getAddress. Let me make it a little easier though.
So the same private keys can generate addresses for either network. That's interesting.
Yep, the comment is the same private key can generate addresses for different networks. Yes, absolutely. So let's create a new private key. Let's call it a key. Don't be frightened by the thing that comes up after that. Bitcoin.ec_key.makeRandom, create a new key. Now let's create a livenet address from the same private key. Since I didn't specify a network in getAddress, it's going to give me a livenet address. Oh, keep forgetting that. Right, so the address starts with a 1, it's a Bitcoin address. Now let's create an address for the Bitcoin testnet. Bitcoin.networks.testnet, we specify that in getAddress. And the same key is used to generate an address for the Bitcoin testnet. Now we are going to fund this address with some coins. So I'm going to look up this address on the Blockchain Explorer. So this is a new address that I created. There are no coins in it. The balance is 0. And that's the QR code that I can send coins to. I'm gonna send the coins from my Block.io account. So I'm gonna
That
send.
address isn't mentioned in the blockchain anywhere though, right? So.
Yeah,
so
that.
chain is just telling you this is empty.
Yep. So that address it has not been transacted with. So the blockchain doesn't actually have it. We just know that the address is valid. So that's why the Blockchain Explorer is showing it. Now I'm going to send some coins into that address. So I'm going to send 0.001 Bitcoin testnet. Just creating the transaction, signing the transaction, sending it. And over here you see immediately the balance has changed. That's how fast it is. That you don't need to wait 48 hours for money to come from Australia or somewhere else. That's how fast it should be. And that's how fast Bitcoin is. And now the network is waiting for miners to validate this transaction. Okay? So now what we're going to do is we are going to create a new transaction and we're going to spend these coins. Okay? Remember, a transaction is a set of instructions. You take the coin from somewhere and you give the coins to someone. Right? So let's go into that.
Question, are all these commands that you've been entering, are they going to be available later? Because I'm not able to keep up.
Jeff, you writing this down? Okay. So Jeff is writing all of this down for your convenience. If you're not able to follow it, just hold on. Go ahead and stop me if I'm moving too fast. Okay?
That's
We
right.
also create a Google Doc, share a bit.ly link, and then that'll be public, and we can, as a group, share notes on there and record this stuff. Sound good?
Thanks.
Okay. Yeah. Love it when a plan comes together, right? Just to T. Okay, so we've sent some.
I
Yes.
just missed how you send that money, because I have address. Can I do that, or I need to have some bitcoins with me before I send?
You need to have
Base-
some bitcoins
I mean, the
with
base bitcoins with me.
Yeah.
Okay, so I only have, I think, one I got when I signed up for Block.io yesterday.
Yeah. Go ahead and create an address on the Bitcoin testnet and send some coins into it. Yeah. If you have trouble with that, we're gonna work on it
Oh, okay.
afterwards as well.
Oh, okay. I thought you did that already.
Yeah, no, go ahead. Okay, so now we have to create a transaction that spends these coins. Now, what are the core, what is the core information I will need from this transaction? So, remember, a transaction is a set of inputs and a set of outputs. So I need somewhere to send those coins to. Let's generate that. Let's create another random key called key2. Okay. Right. So I'm going to create another random key. It's going to give us a lot of scary data, and this will go away. So I'm going to press enter in 5. Yes.
Alright, so that document is available at the link bit.ly/ lowercase b, lowercase u, capital N, OTES. So BU notes with the N capitalized. That should be editable by all of us.
Right, so we're going to create a new key right now. Done. Now we're going to get a Bitcoin testnet address out of it. So I'm going to do key2.pub.get address, Bitcoin networks testnet. I'm going to convert that to a string. Let me know if I'm going too fast, by the way. Okay, everyone got it? I'm going to press enter now. get an address out of it. Okay, that is the address I'm going to send the coins to. So I'm going to take the coins from this address and I'm going to send them into this address that we just created. Now, how do I do that? I have no idea. I'm going to look up some docs. Right, so this is the website of Bitcoin.js. They give you an example of creating a transaction. So they're saying, if you want to create a new transaction, type tx equals new bitcoin dot transaction with a capital T. Then you add an input to it. Remember, a transaction is a set of inputs and outputs. Right, so we are going to add an input. Then we're going to specify the source of the coins. The source of the coins is the transaction ID and the input number. Right. So over here, it will be the output number. Sorry. So over here, this is the transaction that we received the coins in. So we're going to take this ID of the transaction. And we're going to look at which output we can spend. We just created the key for output number 0. So over here on the Bitcoin.js site, where it says tx.addInput, we're going to specify our transaction ID and the output number 0. Right? And then we're going to specify how much of the coins to send to the destination with tx.addOutput, and then we specify the address, and then we specify the number of coins we are going to send. Now, note that every single Bitcoin is divisible to 8 decimal places. That means 1 Bitcoin is equal to 100 million Satoshi. Satoshi is the smallest unit of account on the blockchain, on the Bitcoin blockchain. Right? 1 Satoshi, 1 Bitcoin equals 100 million Satoshi. That's 100,000,000 Satoshis. That's 1 Bitcoin. So just to drill that in, $100 million Satoshis equal to 1 Bitcoin. And note how there are 8 zeros over here. If you go and look up on the Block Explorer, it's gonna show you to a precision of 8 decimal places. Right? That is because it needs to show you exactly how many Satoshis are in each input and output. Right? Okay, so in Bitcoin.js, it wants you to specify the amount in Satoshis. This guy is not actually trying to spend 15,000 Bitcoin. He's spending 15,000 Satoshi. Right? So once we create the instruction, take these coins from the input and give them to this output, we are going to sign the input. Remember, the input was previously an output, and the previous output had specified only allow Atif or anyone owning the private key to this address to spend these coins. The way I specified that I actually own the address is by signing it with the private key. So over here you say tx.sign, sign the first input, which is input 0, and then you specify the key that you want to sign it with. Anyone that has the private key can sign it. Anyone that does not have the private key can only create an invalid signature. Okay? Right. Now let's do that in practice. Now I might lose you over here, but if you have not transacted on the Bitcoin network, on the Bitcoin testnet, we can follow up with you after this thing. But if you want, go ahead to your block.io account and send some Bitcoin testnet into the address you created. And if you look up that address on a block explorer that supports the Bitcoin testnet like chain.so, you should be able to see the transaction. You take the transaction ID, which is this. I'm going to copy that, and you're going to note the output number that you want to spend. For us, it's output 0. Okay. So I'm going to do that over here. I'm going to create a new transaction, add an input. That's us creating a new transaction. That's us specifying where to take the coins from. So we specify the transaction, we specify the output number, and we use that as the input instruction for this transaction. Right. So we add that input, and we're going to specify where we want these coins to send. So we're going to take the second address that we generated with key2.pub.getAddress. We're going to add it as the output. And then I'm going to specify the number in Satoshi. So I'm going to do...
I have a quick question. Do you need to specify that the transaction is being broadcast to the testnet instead of, like, in the transaction parentheses?
Yeah, in a bit.
Okay.
So we're just creating a generic transaction right now.
Okay.
We're not actually broadcasting it or pushing it into the network. That happens in a bit.
Okay.
Yeah. So I'm gonna specify in Satoshis how many coins I want to spend. So we're gonna include, we had 0.001 Bitcoin to spend over here. We're gonna let the network have 0.0001 of those Bitcoins as a transaction fee. So how many coins do I want to actually be received by this address? I'm gonna say 0.0009 multiplied by the number of Satoshis. Okay. Don't handle numbers as floats like I am right now on anything in production. This is just for a demonstration. You should be using big integers and big decimals. Alright, so I'm going to add the output. Okay, I added the output. Now, we added the input, but we didn't sign it. The network has no way of knowing that these coins were actually, I actually wanted to spend them, so I need to sign that input. I'm going to do that right now. So key, the variable key, was the one that held the coins that I just sent to. And we're going to sign the first input, which is 0. So you sign that, and Bitcoin.js is coming up with saying, hey, we changed this API, so you're not going to be able to use it at a later point. We don't care. We can use it right now. We can be politically correct later on. Right. So we have created an input, we have created an output, we have signed the input. Should be good to go. So let's get a concise representation of this transaction that we can push into the network. Okay. So we're going to get the hexadecimal equivalent of this transaction, this packed formed transaction. We do that with tx.to hex with a capital X, H. Right. It comes back with this transaction. And this is the kind of data that is exchanged between nodes on the Bitcoin network. Okay? And then you unpack that and it looks pretty separated into inputs and outputs and scripts and so on. All of that is packed into this concise representation in hex form. So we're going to take this string, and we're going to push that through chain.so. So let's look at how to do that. So if you go to the blockchain API on chain.so, it has a part where you can send transactions into the network. So it's saying if you want to send a transaction into the network, you have to make a post request into this endpoint API v2 sendtx. And if you're using Linux or Mac, you can just follow this example given. So we're going to follow this example given, and that is how we will send transactions into the network. So I'm going to type that in a new window. So right now I'm specifying that I want to send a transaction on the Bitcoin testnet. So the abbreviation that chain.so uses is BTC test. And then I'm going to post the data with the variable name tx hex. Then I'm going to paste the transaction hex in it. Looks scary, but it really isn't. Good?
Question.
Yes.
Did you add the script to the transaction?
Right. So the question is, did we add the script?
Yeah.
Yes, we did. So where Bitcoin JS lib was handling that part by itself. So when we said add input, it added the input and it added an unsigned script. Then we signed the input, okay, and then we added an output. It added the script with it. We didn't need to specify it. We can specify it if we want to, but we're not there yet. Okay. We're going to do that in the next one, by the way. We're going to embed some data into the blockchain next. All right, let's push it. Let's see what happens. Okay. So we made the call to chain.so and we said, push this transaction into the network. Chain.so comes back to us and says, here's the transaction ID on the network. This transaction ID is basically a hash of the big string you see up there. Right, so let's go look it up. Right, so if you look up that transaction on chain.so, it immediately says, yep, coins were spent from MWWBZQ into the address of our choice. Good? Any questions?
So because we didn't send, we didn't put another output back to our change address, then we theoretically lost the other coins. Is that, or they're as fees?
So there is one input and there is one output because we were taking the coins from the input and we were consuming them all except for network fees because we want to give the miners some incentive to include this transaction in a block. Right? We want it to be validated quickly. This fee is pretty low for being validated extremely quickly because the Bitcoin network is experiencing very large volumes these days. But something's better than nothing. Right? When you specify the amounts you want to spend to destinations in a Bitcoin transaction, anything that you don't specify needs to go somewhere will go as a transaction fee. Okay? So there have been transactions where people have spent like 26 Bitcoin as transaction fee. 26 whole Bitcoin as a transaction fee. I don't know if they got it back or not.
how does mining work on the testnet? Is that a thing? Do people mine on the testnet? And I mean, it's not real money, so there's no incentive to do it.
Like the question is, why does
How does
the
testnet
Bitcoin
work?
testnet, why does the Bitcoin testnet not hold value to people?
Well, how does it work? I mean, because nobody has any incentive to.
It is exactly the same network, except people are just doing testing stuff on it. So, some people like to test their ASIC miners before, like Butterfly Labs or whatever.
Okay.
They will try to test their ASIC miners on the Bitcoin testnet before they push it live. While they're doing it, they're actually mining other people's testnet coins. It works out. Sometimes you won't see any miners in there.
Miners need testing.
Yeah. So sometimes you won't see any activity in there. So for example, if you go to the Dogecoin testnet, you see very little activity in here because everyone just tends to use the Bitcoin testnet. It's the same network. So you don't need to go to, and then if you want to look at something even more dead, go to go to the Litecoin testnet, and it's a ghost town. And sometimes you will see people are not mining at all. There's just no one in there, which is fine. People are just using it to test stuff. Right. So we created new addresses. We sent some coins from one into another, and that's cool. There was no cheering, so it really hasn't set in yet, I think, that we created a transaction and pushed it into the network, but it's okay, you can sleep on it. The next thing we are going to do is, you guys must have heard a lot about, we can embed data into the blockchain and it will be logged there for eternity. Isn't that cool? Isn't that phenomenal? Yes, it is. And we are going to do that today on the Bitcoin testnet. We'll see how simple it is. Just because it's this simple, it's really easy to bloat the blockchain as well because everyone is storing the entire ledger in a lot of different computers. So you will bloat the blockchain when you do it, but we're okay, we're doing it on the testnet. Right. Okay, now we sent some coins into our key 2 address. We're going to spend the coins from the key 2 address into our key 3 address, which we are going to just generate. Right, so we're generating a third address. Scary stuff. And we're going to get the address out of it, out of key 3. That's the third address that we're using for the Bitcoin testnet. Right? Okay, now let's create a transaction that sends some coins into this address and embed some data within that transaction. Okay, so we're going to follow the same steps as before. We're going to go back to the transaction that we just sent. And so this was the transaction ID, and the output we are trying to spend is output number 0, right? From our key 2 address. I'm going to create another transaction called TX2. So I'm going to use the coins that I just sent to the key 2 address as my input in this transaction. And then I'm going to add an output. Right, so that output had 0.0009 Bitcoin. I'm I'm gonna leave 0.0001 Bitcoin as the transaction fee and specify the rest as Satoshis. Right? Makes sense? Now, how do we embed data into this thing? Let's figure that out. Let's Google it.
Should you be adding the inputs and outputs to TX2?
Sorry, yes, go ahead.
Should you be adding the inputs and outputs to TX2 or TX?
Oh, my bad. Yeah, good catch. It's TX2. Yeah. Okay. Yeah, I was wondering why I was saying one over there. That's because that's the number of inputs and outputs it's at. Yeah, so TX2 add input, TX2 add output. Now let's figure out how to add data. So this is something that we will cover probably in the next session, which is the Bitcoin scripting language. But remember this, that if you need to embed some data into the Bitcoin blockchain, the standard used is by using an opcode called op-return in the script. Let me specify what that is. So if you go to the outputs, the scripts for a transaction, you will see it starts with op duplicate, op hash 160, from the hash 160, op equal verify, op checks it. These are instructions to the recipient on how to verify transactions. Right? If you need to embed some data into the transaction, the standard used is get rid of all of this and say op_return and then hexadecimal representation of the data you wanted to embed. Make sense? So we're going to do that now. Now the syntax for this is it's bad, but we're going to do it anyway. So we're going to embed the data melons. Actually, you know what? Let's embed the data blockchain U number 2 in there. Right, so we're going to create a buffer. That buffer will basically take a byte representation of this string, which is blockchain U number 2. And it's going to assign that to a variable called data. If you don't know what buffers are, don't worry. Just use this for now. You don't need to understand everything in one go. It's an iterative process. Okay, so that string blockchain U2, this is the hexadecimal representation of it. This is what we will embed into the blockchain. How do we do that? So what I'm doing is I'm taking a Stack Overflow answer and I'm using it. That's how I've always learned how to code since I was a kid. So it's saying specify Bitcoin opcode by saying bitcoin.opcodes.opreturn. So it's saying Bitcoin, create a script from these chunks of information. So it's saying bitcoin.script.from chunks. There in parentheses, it's specifying an array of 2 values. we've specified the first value, which is bitcoin.opcodes.opReturn. And the second value is the data that we wanted to embed. Right? Okay. Now the result is a Bitcoin script in whatever form Bitcoin JS uses. Right? And we're going to add that to an output. So we're going to say tx2.add output. We're going to say tx2.add output. We're going to specify the script, and we're going to specify the amount of satoshis we want to go into that script. Remember, you're just embedding data into a transaction with this one output. Right? If we send any coins into this output, those coins can never be spent again because there are no instructions to validate spending of those coins. Right? You haven't even specified that anyone can spend them. Those coins will be gone. No one can claim them ever. So when you embed data in an output, don't specify any coins to be sent into that. Okay?
So when you added that input there, did you get that from SoChain?
Yep.
And it was the output address of your last transaction, right?
Yep.
Okay.
The question is, when you added the input, there was a transaction ID you added. Where did that transaction ID come from? It came from the last transaction that we made. So if we go to
But it's not the output of the transaction, it's just the transaction ID.
transaction ID, yeah, you need to specify the transaction ID
Transaction ID
and the output number.
So it's just the transaction ID, a transaction has multiple outputs.
It's just a
so
transaction ID and
specify which one.
And you specify the output number.
Thank you.
Sure. So we are adding an output with some data embedded in it. Now let's sign this input that we added up there with the key. So we used key 2 to create that address. We're going to sign it with that address. Right? And so let's revisit it. We've created inputs. We've created outputs. We have signed the input. That's it. The transaction should be good to go. So we're going to get a concise representation of it in hex form with tx2.2hex.
That'd be key 3.
No, it won't be key 3. Key 3 is just an address we're sending the coins to. It's not the one spending it. Right, so we have the hex representation of this transaction that is embedding some data. So let's push that through SoChain. Right, so we're saying post this data, that is tx_hex equals the hex string to the transaction broadcast endpoint at SoChain. When we do that, the transaction went through and we get a transaction ID on the network. Let's go look at what we did. Okay. So we created a transaction. We tried to spend coins that were 0.0009 bitnet, and we sent the coins into our key 3 address, which was this address. And then we created another output in which we wanted to embed some data. Since we wanted to embed some data, we weren't attaching any conditions on who can spend these coins or whatnot. So the standard way of doing that was embed some data, but don't send in any coins. Okay, so we did that, and you can see the instructions that are valid for some coins to be spent are opt-up, hash 160, some other Bitcoin scripts or opcodes. And then for the embedded data, it's up returned and a hex representation of the sentence blockchain U number 2, right? And SoChain is actually trying to decode it on its own. So it's saying decoded blockchain U number 2. That is the message that was encoded in the transaction.
So anybody could see that information?
So the comment is anyone can see that information? Yes, anyone can see that information. As long as this testnet lives. Right? And that's it. You just embedded some data in the blockchain. That is amazing. And there was no cheering again. So,
You didn't just embed data in blockchain, you have a time that you embedded the data in blockchain, and that's important.
yeah, it's not just data embedded in the blockchain. There's a time attached to that, an approximate time. And that is amazing. So that's it. That's for the session. First one. Now we're going to talk about what you will do as homework. Because the more you do on your own, the faster you'll be at mastering this thing. So once you go home, or right after this session if you want, go and play with some free online blockchain APIs out there. There are a number of them. There's blockchain.info, there's SoChain, the one that we just used. If you want to do it for Dogecoin, there's dogechain.info. If you want to do it for other currencies as well, there's blockr.io, blockreader.io. There's bitcore.io by BitPay, which is an open source tool. You can download and install it on its own. Might take you a bit, but it will work. One of the things that we want you to do, or want you to at least entertain, is find out whether transactions outputs have been spent. What does that mean? That means whenever a transaction occurs on the network, that transaction can either be untouched or unspent, or it can be spent. Right? We want you to find out whether an output was spent or not. And you can use that, the Blockchain Explorer tools that we've mentioned, to do that through the APIs that we offer. The second thing we want you to do, and this is going to make you pull your hair out, is convert a random integer into a private key. Or don't convert it to a private key. Just assume that is the private key. Convert it into a public key using the ECDSA cryptography curve, and then get a Bitcoin address out of it. The easiest thing you can do is look at the Bitcoin JS lib source code. It's all there. You just need to understand it. What this will do is it will get you a lot more acclimated to JavaScript and Node.js or whatever other language you want. You don't need to be restricted to JavaScript. I personally love Ruby and Python. So just go back and try to do this in any language of your choice. And if you have trouble with it, open up the source code for an existing implementation and find out how to do it. And if you can't find out how to do it, we're only an email away. And next week, we'll only be a couple of feet away. Right? Okay. All right, good. Until next time, guys. But don't go anywhere. We'll be there. All right, so Robert is supposed to shepherd us. Okay.
The sand is failing.
Sorry?
The sand is failing.
Yeah, you gotta specify,
About 5 more minutes for food, everybody?
Oh,
And, who doesn't have a
the
badge?
transaction is invalid, you made some mistakes.
Who doesn't have a name badge?
Well,
Just
it
come
gives
to
you
me
the
if you don't
entire